Hey everyone! In the world of AI, there's this quiet revolution going on. It's not something you'll see on the front page, but it's happening right at the core of how computers, how they think. And this change, it's making AI smaller, faster, and way, way smarter. So this all kind of kicked off with this just wild claim from NVIDIA, the chip giant. They unveiled their new Blackwell architecture and promised get this, a 7 times performance boost for training AI. Now, to put that in perspective, in the world of computing, a 20% jump is huge. That's a big deal. 700%, that's almost unheard of. It's insane. And NVIDIA, they're not calling this some minor tweak. No, they're calling it a strategic advantage. So the big question is, how is that even possible? Well, the answer lies in this hidden battle that's being fought over something incredibly small, but unbelievably powerful. Yeah, so this massive leap we're seeing, it's all thanks to this fight over what's called numerical precision. Now, what is that? Well, it's basically the language computers use to speak math. It's this invisible engine that's chugging away in the background, but it's driving literally all the progress we're seeing in AI. For years, the gold standard for data was something called FP32. The easiest way to think about it is like 4K video. It's super detailed, really rich, but man, it is heavy. So the industry started to slim down. First, we moved to 16-bit, which is kind of like going to 1080p. Then we got to 8-bit. And now NVIDIA is pushing the absolute frontier down to just 4 bits. I mean, that's like going from a full-blown video to pixel art. It's radically smaller for sure, but the real question is, can it still capture the whole picture? Okay, so to really get why this AI diet is such a big deal, we need to peel back a layer and look at how computers actually handle numbers in the first place. Right, think about it. The real world has this infinite rainbow of numbers, right? So how on earth does a computer, a machine that only gets zeros and ones, capture that entire spectrum? Well, the answer is something called a floating point number. And honestly, the best way to think about it is like scientific notation from your high school science class. It's a clever shorthand that balances how big or small a number is with how much detail it has. Let's actually break this down with a camera analogy, because it makes it super clear. First, you've got the sign. That's easy, right? Is the number positive or negative? Done. Then you have the exponent. Think of this as your camera's zoom lens. It sets the scale, letting you see things from the cosmic, like galaxies, all the way down to the atomic. And finally, you've got the mantissa. This is your resolution. It's the megapixels that capture all those tiny, fine details. Okay, and right here, this is the core conflict. This is the catch. Using lower precision, fewer bits, means you can train AI way, way faster. But it also creates these tiny little rounding errors. And in a massive AI model with billions of calculations, those tiny arrows can pile up and up and up until the whole training process just completely fails. It just collapses. So you can see every single one of these formats has a trade-off. You've got FP32 at the top. That's your 4K Ultra HD video. It's gorgeous, super stable, but slow and memory hungry. As you start moving down the list to things like FP8 and now this crazy NVFP4, you get this extreme speed and efficiency, but you're constantly risking losing too much detail. It's a massive technical challenge to make this work. All right, so to solve this huge challenge, 2 really different philosophies have popped up in the AI world. And it's kind of like a tale of the architect versus the alchemist. So on one side, you've got the alchemists. Think of companies like DeepSeek. Their whole thing is using super clever software and algorithms to squeeze every last drop of performance out of the hardware they already have. Then on the other side, you have the architects, like NVIDIA. They design brand new chips and software together from the ground up for absolute peak performance. So how does this software alchemy actually work? Well, DeepSeek uses some really smart tricks. For instance, they use something called mixed precision to protect the most sensitive parts of an AI model while using lower precision everywhere else. They also have special scaling techniques to handle those really extreme outlier numbers. And what's really interesting is that this is also a strategic response to the US chip export controls. It's a way to get the best possible performance on whatever hardware they can get their hands on. Now, NVIDIA's approach, it's completely different. Their recipe for this 4-bit magic is baked directly into the silicon of their new chips. They're using these brilliant math tricks to kind of pre-fold the data to make it easier to compress, and they're using a much fairer, more probabilistic way of rounding numbers to reduce those cumulative errors. It's a total top-to-bottom hardware and software solution. So what does this all mean? This very technical, nitty-gritty battle over just a few bits is sending these huge ripple effects across the entire AI industry. It's changing everything. For the actual AI developers, the folks at places like OpenAI or Mistral, this is a total game changer. I mean, a 7-time speedup. That means experiments that used to take weeks now take days. Suddenly, the key competitive advantage isn't just about having the most data, it's about how fast you can iterate. This is what allows smaller, scrappy teams like Mistral to actually compete with the giants. And let's be clear, for NVIDIA, this is about so much more than just selling a faster chip. NVFP4 is a strategic moat. It's a wall around their castle. To get that incredible 7x speedup, you absolutely have to buy their new Blackwell hardware. And to use that hardware, you have to use their CUDA software platform. It's a brilliant, absolutely brilliant business move that locks the entire industry even deeper into their ecosystem. Okay, so you might be thinking, this is cool tech stuff, but why should I care? Well, here's why. Because this revolution that's happening inside some giant data center is absolutely going to find its way right into your pocket. It's going to change the apps you use every single day. When you lower the cost of training AI, you're essentially democratizing the entire field. Suddenly, small startups and university research labs can afford to build really powerful models that were previously only possible for a few giant companies. And this just sparks this incredible cycle of innovation that ultimately gives all of us better, cheaper, and way more powerful AI tools. In fact, the cost of running AI is dropping so fast that some experts are saying it's trending towards being too cheap to meter. I mean, just stop and think about that for a second. Imagine powerful AI becoming as common and as inexpensive as a utility like electricity or water. That is the world we are rapidly heading towards. So, as we start to wrap this up, we're left with this really incredible dynamic. On one hand, you have this flywheel of efficiency that's just spinning faster and faster, but on the other, it's also creating what could become two parallel AI universes. And here's that flywheel I was talking about. It's a beautiful cycle. You start with lower precision formats. That leads to faster innovation and bigger models. That, in turn, drives the creation of new hardware. And that new hardware enables even more efficiency. It's the self-reinforcing cycle that just keeps going, delivering better and cheaper AI for all of us. But geopolitics are splitting this path in two. The path in the US is very much hardware-led, right? It's dominated by NVIDIA's integrated ecosystem, all pushing for the absolute maximum raw performance. In contrast, the path we're seeing emerge in China is becoming software-led, using that software alchemy we talked about to squeeze every ounce of power out of their available domestic hardware. And this leaves us with a final, really fascinating question to think about. Are we actually witnessing the rise of two parallel AI universes? One that's defined by having the ultimate, most powerful hardware imaginable, and another defined by the ultimate, most ingenious software optimization ever created. What that means for the future of technology? Well, that's a story that's still being written.